Hello friends, so today we are going to learn about encoder-decoder attention layer working. Thanks for coming to my channel GenAI LLM at the itself and happy learning. Let us start. So the main component that we are focusing here is attentions. So attentions in transformer. There are mainly three type of attentions. Attention, self-attention in encoder, self-attention in decoder, and encoder-decoder attention in decoder. This is the architecture. So here you can see there is a simple transformer architecture which is divided into two parts. The first one is encoder, the second one is decoder. Okay. So in encoder we can see there is an input that is going up. It's combining the input of embedding plus the positional encoding of each of the tokens. Then there is a concept of self-attention followed by other layers. But when the data come to the encoder, then again it's go to the decoder, and there is a concept encoder-decoder attention. At the same time, you can see the target embedding is coming up combining with the positional encoding, and there is one more attention that is called self-attention layer that is followed by the linear and the softmax for the normalization, and there is the output. Now we will go towards how it works the self-attention in encoder. The first concept that we have seen here, the embedding part, right? That is the input embedding. Each input token, that is word or a subword, is first converted into a fixed size of vectors representation using a embedding layer. That is the nature of embedding layer, to convert it into a vector. If positional encoding are used in the code, then it is added to the embedding to include the information about the token's position in the sequence. Fine. Now the second part that comes into picture is how we are representing each token. So each token is represented with the three factors. Suppose there is a token of xi, then there is a concept of query, that is a concept of key, and there is a concept of value. So query is represent the token we are focusing on. The key represent the token we are comparing the query against, means query is the self, key is the one which we are comparing with, and value represent the information of the tokens to pass forward. The combination and the computed is like this: query, this x is the input matrix, okay, containing all the token embeddings combined with the weight of to the exponential of query q. Then key is calculated at the weight similar like the input matrix into weight of the k, and value is computed as the input matrix weight of the exponential of the value. Okay, w key and w value enable weight matrix, nothing more. Now the how we are going to calculate the similarity calculations, that is that I have already explained in one of my videos, query key dot product. That is a concept that apply here with each individual matrix, and there is a dot product, and similarity is calculated by query and key qi into dot product of kj. Now there is a concept of scaling to prevent the dot product values from becoming too large, especially when the dimension of the query and the key is very much high. The similarity scores are scaled by the square root of the dimension of keys, that is dk. So here you can see that it is calculated by scaled similarity of query comma key, then query dot product of key dot product divided by square root of the dimension dk. Then there is a concept of softmax for the attention weights. The scale similarity are passed through a softmax functions to produce the attention weight to sum to 1, that is from 0 to 1 range. Now here you can see the picture, and this is you can see that input embedding and the positional encoding are combining here going to the self-attention layer divided into three trees: structure, value, key, and query. Encoder 1, output encoder 6, fine. Then it's going to the encoder 6, output is coming sequential and embedding, okay. Then it's going to the encoder-decoder attentions layer, value, key, and query, then output. Then here you can see the output embedding and the positional encoding output is also going to the self-attention layers, that is value, key, query, and these both are combined together, normalization, softmax, and then the probability score is coming, similarity score, dot product of everything. Now we are talking about the self-attention in the decoder. The thing here we will only talk about this part where we can see two kind of decoder system, that is self-attention in decoder and encoder-decoder attentions. Input sequence, the decoder received two inputs, the target sequence embedding, that is token generated so far, the encoder output, that is a contextualized representation of the input sequences. Second is the component of the attentions in the decoder. It is having two attention that I have shown you just now in the picture, the masked self attention and the encoder decoder attention. The masked self attention focuses on the target sequences, fine, and the encoder decoder attention are focusing on the encoder outputs. See, the masked self-attention generate queries key value. Here we can see there is a target sequence of y, which is y into y1, y2 to ym. Compute the query of qi weight exponential q, and key is ki y into work of exponential k, and value vi qi exponential of v. So w, weight of exponential of q, weight of exponential of k, and weight of exponential of v are the learnable weight matrix. Compute the attention scores. Then we are calculating attention scores of ij into dot product of query and key. Okay. Then we are doing the mask future tokens to ensure that decoder does not peek ahead, apply it, so that it should not have the value out of the range, and so that we have to apply a mask to the scores to block the attention to future tokens. Okay, set scores of the future token to infinity. Now here scaling of the score concept comes here. Here the scores are getting scaled by the square root of the dimensional decay. Here is score what we are getting, we are dividing it by the square root of decay. Then we apply the softmax of the mask score that we have received before of ij concept. Then there is the concept of weighted sum of values, where we add all the values that we are getting, sigma of alpha of aij, that softmax output, plus v of j, that is value vector of vj. Now here now I have shown you that this is an encoder decoder attention, that is a cross attention. We call it as a cross attention also. Cross attention generate a cross attention queries. Every attention has its own three branches, query key and value. So use the output from the mask self attention layer as input. The query key y that is a dimensional work exponential of q, okay, weight of the q. Then use the encoder output of h1 h2 h2 generate. Then there is a concept of keys, where we are seeing the different parameters of output, key value is calculated. Then again the cross attention scores are calculated by the dot product of query and key. Then we do the same procedure of scaling, softmaxing, and weighing of the sum. Now in that way the encoder decoder attention is also been calculated. So guys, I have kept it so crisp and understanding, so that everybody can understand how these three works around. But still, if you need more detailed explanation, then please let me know. I will happy to share and more and more. I want to keep the length of the video also small, so that you don't get bored. Okay, thank you so much. This is my channel GenAI LLM at Self. Please like and subscribe. Happy learning.